All right, and right for our last talk for today, I've got a collection. So Allan's giving us a talk about images, which of course is obviously what a whole lot of the rest is built on. So it's good to go back to the fundamentals of here.
Thank you. Good afternoon. So yes, images for containers, Docker, whichever one. I don't care about your runtime or anything like that, but I've got some examples, and I'm using Docker as the language as a part of that, just because it's what I'm most familiar with. So Docker images, what are they anyway? They're just like a baseline definition. They're something that's reproducible, something you can reason about. Really just a set of instructions to prepare some sort of execution runtime. They're a great way to also reason about certain conditions under which applications and whatever sorts of services, binaries, executables will run. They're also really handy where to be used as a caching mechanism of sorts. So you might have some long computation that needs to happen ready for an application to be executable. And if you do that ahead of time, if you can do that ahead of time, then you might save a lot of time later on. This is also the case for dependencies. So if you have a lot of compilation, maybe there's a lot of C libraries you need to compile those, then as you're debugging your software, you don't want to recompile all of those deps every single time you make a change. So you can use images as a way to have those pre-compilation steps already done and just reuse them over and over again. One of the great things about images is they give reproducible ecosystems. Once something's sorted out, it's ready to go, you can reuse it over and over again, and it will work the exact same way. So that way, we have this fantastic expected environment that is ready to go for everyone. Inside each image, there's a series of layers. When you add commands, whether that's a shell command or a copy command or something else, I can't remember which one, a layer is created. And a layer is kind of a snapshot of the diff of the file system from within like a temporary container. And that's used to make up that layer. And so layers on top of layers. So that way, when you run a container from an image, you get all of those layers flattened down to one file system. To make things nice at runtime, well, ready for runtime, not necessarily at runtime, minimizing these layers can save a lot of things like bandwidth or storage costs, or just make it a bit easier to backtrace things over time. If you've got a lot of layers and some sort of weird change is a part of your final image, if there's lots and lots of layers, it's really hard to pinpoint where that change was introduced. And as I mentioned earlier, the layers are there for the caching mechanism. So with the pre-compilation of dependencies, you might add just a particular section to cache those in particular, and then when you rebuild the image, the cache will get picked up straight away and save a lot of time. So really, when you're thinking about building images, you want to try and structure your image definition to make use of the layers and get as most bang for your buck, depending on whatever your needs are. Every container uses one of these images. Whether or not you've built the image yourself, there's some sort of definition. There are heaps that are available. Doesn't really matter. Languages, applications, there's a lot already out there. So it's entirely possible. You may not even build your own images anyway. You'll just use them. You'll bring in some other, like you'll mount a file system, which will just have your application code and then run. So if you can, you might want to build your own image just to speed things up a little bit. mounting file systems, volumes. It can get a little bit tricky, especially if you're doing many, many things across many servers or whatever your infrastructure looks like. Every additional step takes time. So if you can get your image spot on, then running it many times might save a lot of time, even though each one is only just a fraction. So in terms of our execution environments, I've split up a bunch of scenarios under which images would be different to reason about. And this is more of you have one application, but you have many different ways that you interact with it. You might deploy it, you might develop on it, you might run it locally somewhere that's not like production, but you might think about it as sort of production. So when you want to deploy a container somewhere, you want to have an image that's ready to go as is. You give it a command and it does its thing. No worries, you don't have to think about it anymore. You want to make sure that you've got all of the necessary tools available to have your application running exactly as you need it to run. And it also depends on where you're running it. So within Kubernetes, for instance, you might have different monitoring capabilities. You might have a daemon for some sort of Prometheus or Datadog exporter or something like that to push metrics back out to your Kubernetes daemons. Maybe you have external exporters or that will pull data from your application. Same with the logs. So you can either pre-install these things or your environment might already do it for you. So a very simple example, we want to keep it as small as possible. So we would go ahead and have a compile stage. We copy across our code, and then we compile it. I'm using Go in this case, primarily because it's what I normally develop in, and it lends itself well to very simple examples in this case. Apologies for those who dislike Go. And ready for deployment, we would take a second step. We go from scratch, which is roughly an empty file system, and we just copy that binary out. And so we end up with an image at the end that only has one layer, and that one layer consists of just a binary. So it's probably, 6 meg? And that's it. There's no shell, there's no other executables. If something goes wrong and you leave a backdoor, there's nowhere for an attacker to get access to. Unless you build that into your binary. Another scenario is in CI and testing. CI testing, there's additional tools that are usually like you want to make use of. You wouldn't want to deploy debuggers or other code coverage test frameworks. You wouldn't want them running inside of a deployed container. But you would want them available during testing, so that way you don't have to go and install all of these during your pipeline. Really, when you want to run your tests, you should just be able to run them. So all of those dependencies should be ready to go. The good thing about this, you've got two images now, but they're quite different, and they're meant for very different purposes. But having them ready to go up ahead of time will save a lot of time in the long run. For this instance, we have a lot more that we want to do. And because it runs during CI, the layers don't necessarily matter as much. In this case, I've kept everything inside of this one run command, which would get a little bit tricky to debug if you have any problems with it, but you don't tend to rebuild it very often. And when it gets run during CI or testing, your executors such as Jenkins or something else is probably going to cache the image locally anyway, so it won't just keep downloading it. So again, we start off just with an image. We copy, say, Prometheus prom tool if we have some sort of Prometheus that we want to debug. And then we bring in a bunch of dependencies just from the command line tools. And then we set up, say, our linter, our coverage generator, AWS CLI, whatever else it is that we need. Once we build the image, we push it to our registry, and then our CI tool can make use of it whenever it needs to use it. Worst comes to worst, we can always pull this locally as well, and that way we don't have to install any of these tools in our local machines. Speaking of local, we have one other idea I was thinking about. So not just for development's sake, but let's say I have my own server at home. I've got my own NAS. I've got a bunch of storage. Maybe I want to run a home media setup. Maybe I'll use Kubernetes, just for the sake of being able to run a bunch of containers. So I might want to deploy a service or an application of mine into that cluster. I could use my production image because that's what it's there for. It's there to be deployed, it runs, that's it. Only difference is that in my own cluster, I'm probably not going to be running the same tools as a proper production environment. In production, I might be running some crazy Prometheus cluster that gets a whole heap of metrics pushed to it, and there's probably an ELK cluster somewhere with petabytes of storage ready to be filled up with very useful logs. But locally, that might not be the case. So I might want to run things slightly differently. But I also might just want to do the same thing. The big difference here with production is the addition of curl, because it's good for debugging sometimes, and bash. But sticking with Alpine, so it's still relatively small, and we don't pull from scratch. And that way we've got roughly BusyBox, but Alpine available. So locally we can still SSH in. We can get a bit of visibility, we can poke around, we can make sure it's all good, but slightly different to production. Development, on the other hand, is a bit more tricky. We could be tempted to just bring everything in, use the same sort of setup as what we did with CI and testing, and just be done with it. But do we really want to do that? It's not quite the same. There's slightly different tools. Maybe we want to have a debugger locally, but we wouldn't necessarily want that in testing. Or maybe we would have different images that we would use, say, for the AWS CLI. So we can do it differently. In this case, maybe we actually want to have a full application that we build a front end as well. But we don't want to separate our front end and our back end too much. So we might bring in Node and Yarn, and that way we can compile and generate our front end assets. And because maybe we want to pull them into the Go binary. So when we have finished building our application, we just have one binary. There's no JS or CSS that we need to include from somewhere else. So we can do that here. And then for our development, we've got all those tools ready to go in that one container or one image. One of the really useful things about images and building them is the concept of multistage builds. This was back what was used in the production image, where we have multiple from statements, and we can pick and choose what happens in different sections, and then it's only the targeted from section that the layers get kept as a part of that image itself. So it means that we can cache bunches of steps. We can pull from different base images. We can have completely different environment commands run to pre-generate a whole bunch of stuff, but what we end up with at the end is just a very simple, basic setup. So in this case, taking that front end or full application. We could start off with, say, using the node image. We can give it an alias just to make it a bit nicer to reason about. We'll call it FE. We copy across our application code, and then we yarn build. It'll do its thing. You know, there's a whole heap of dependencies it'll pull down, whatever other processing. We'll end up with some compiled assets at the end. And then we start our next stage. And from this stage, we would start with Go. And then again, we copy across our local file system, but then we can also copy across those compiled assets from the front end build. So there's no node, there's no yarn, there's no front end component as a part of this second stage. We just pull whatever was already compiled because we can take that from this first stage. We can then go ahead and compile our final binary, which will pull in those assets as bin data, and it's ready to go. So considerations, there's a few to think about when it comes to the deployed image. This is the one that I have the most discussions about with people talking about images, because oftentimes people just end up with a kitchen sink approach. They install everything, they have PHP running, they have Ruby in there, they've got Node and whatever else. But really, they're just running a Go binary, so it's why do they have all of these things installed? Not only does it use bandwidth, it also opens up a lot of security holes, and it's just hard to work with. So one of the biggest things is to think about the environment that a container running from an image is going to be running in. If you're running in a Kubernetes cluster, there's a very good chance that you've already got some monitoring and log capturing tooling. So you probably don't need to have any of those tools pre-built into your image. You also can get a bit tricky with the way that you actually run things. One of my favorite examples is what I've mentioned here with PHP FPM. I've seen some setups where 2 images are being built for a single pod to run 2 separate containers, one for Nginx and one for PHP FPM, but they're being built as separate images. So instead of just having Nginx running and proxying to the other container, they have built a second image. And the most common excuse I was given was that, oh, Nginx needs to serve static assets, so it needs the file system. And I'd say, well, that's great. Why don't you just create a shared volume and mount it into both, and then put the files into that volume? And they just stared blankly at me for 5 minutes. But it's easy enough to do in setups such as Kubernetes that have a very comprehensive definition that allows you to set up that type of execution. Another big concept is making sure that you can inject the right configuration. So an image shouldn't have information about the environment that it's running as. So a container that is an execution of an image would know that it's running in production or staging or local development. But the image itself has no concept of this. It might have an environment, variable environment, which it would then use in place of knowing about any of those individuals, but that should really be it. All the images should be agnostic, and that way they can be applied without having to be rebuilt over and over again. There's a few little bits here extra. I'm a big fan of using Docker ignore. This way you can use copy ... rather than having copy individual file, because each copy will add a separate layer, which becomes bad, or can become bad. So some of my Docker ignore files have 50 lines just to get rid of paths. But really, my big point with a lot of this is just to prepare a bit ahead of time. 15, 20 minutes now just to reason about how things will run can potentially save a lot of time, a lot of bandwidth, and a lot of cost later. Use scanning tools just to check for various defects, vulnerabilities, whatever it might be. A couple I've played with before are Dive and Claire, and I've added the links down the bottom here for those. And yeah, caching is one of the biggest benefits in general here, especially just with the images and having them ready to go. Thank you very much.
Any questions?
Yeah, any questions?
So I think if I tried this, my devs would freak out and say we're deploying different things to dev than what we're going through in production, therefore it's all inconsistent stuff.
Yep. So the way that I've tackled this in the past is to build, say, a deployed image during the CI process, and then run that in the CI process and, I guess, simulate traffic. So that way you're still deploying the same image to your production infrastructure, but in dev, like, you might still piggyback from the same OS. So your dev environment would have like a full Ubuntu setup, but your prod you built from Ubuntu, but depending on your language, it might not run inside of Ubuntu. Go is the example because it doesn't need a full OS, but Ruby or PHP or a whole bunch of others, you need all of the accompanying environment set up and available. Those sorts of things are very good to consider, and you might not end up going down a very hardline approach as what I've discussed, but there's still a lot of things that you could take away to save time or effort.
Thank you very much, Alan.
Thank you.